Today we'll talk about the difference between temperature, internal energy, and heat. This provides the stage for our study of thermal physics in this topic. Let's start from temperature T. You already have an intuitive understanding of temperature as a measure of hotness and coldness. Let's start off with something that might be new to you. Although this glass of water on the table appears to be stationary or motionless, there is actually a lot of motion happening at the macroscopic level. All matter, whether it is solid, liquid, or gas, is made up of constantly moving atoms, or molecules, or particles. However, for the purpose of this presentation, I will call them all as atoms. The motion here could be translational, rotational, or vibrational. Because of this random motion, each atom has kinetic energy of 1/2 mv squared. This picture illustrates the random motion of atoms in a substance. The atoms move in a random direction with different speeds. The color of each atom represents the amount of kinetic energy it has. Although some of them have the same kinetic energy, which is indicated by the same color, they may move in different directions. The average kinetic energy of each atom creates an effect that we can perceive as warmth, and the degree of warmth is called temperature. So the temperature is the measure of the average kinetic energy of atoms in a substance. Even if there are kinetic energies other than translational, you will discover later that it is mainly translational kinetic energy that contributes to temperature. Now, what about the unit for temperature? Celsius is a temperature unit that is widely used. You may have also heard of Fahrenheit. Converting between them is merely an arithmetic exercise, and not really physics. For that reason, we're not doing such an exercise here. For scientists, another unit called Kelvin are commonly used. And in IB physics, we will use both Kelvin and Celsius. The relation between Kelvin and Celsius is given by this formula. The temperature in Kelvin is equal to the temperature in Celsius plus 273. Next is internal energy U. In addition to the kinetic energy, there is also potential energy due to attraction between atoms. This graph is the plot of potential energy that describes the interaction between atoms. Here we have two atoms, and let the center of the first atom be at the origin and the center of the second atom is at a distance r away. When the two atoms are separated by a few atomic diameters, such as this, the nature of the interaction is attractive. As a result, they exert attractive forces on each other. However, if they are close enough to each other that the electron shells overlap, the interaction is repulsive. So they will repel each other. There is an equilibrium distance between these two limits at which the two atoms form a molecule, or they will sit in a regular lattice in the case of solids. If we displace one of the two atoms slightly out of equilibrium, they will oscillate. We can think of this as there were a spring connecting the two atoms. In this condition, the two atoms are bound to each other. The binding energy is large. The internal energy U is the total kinetic energy plus the total potential energy of the atoms in a substance. Notice that the potential energy is recorded as a negative quantity. A negative potential energy value indicates that energy must be added to the system in order for the atom to overcome the attractive force and lower the binding energy. We'll go over the examples later when we learn about phase changes. The last thing is something called heat. The symbol we use for heat is Q. Heat is the energy that a body transfers to another as a result of a temperature difference. This example might help you understand the difference between temperature, internal energy, and heat. Suppose we have objects A and B having different number of atoms and energies. Let us assume that these objects are gas, so we can ignore the potential energy between atoms. The value of the energy here represents the kinetic energy of each atom. What happens if we bring these two objects into contact with one another? Some atoms with higher kinetic energy from one object will collide, transferring some of their kinetic energies to other atoms with lower kinetic energy from the other object. Initially, object A has internal energy of 72 joules. Remember that we ignore the potential energy between atoms. Therefore, the internal energy is just the sum of kinetic energies. The average kinetic energy is 24 joules per atom. This value tells us about the temperature of object A. It should be noted that this value is not exactly the temperature. The precise relationship between average kinetic energy and temperature will be revealed in topic 3.2. Object B, on the other hand, has internal energy of 80 joules and average kinetic energy of 16 joules per atom. There is temperature difference between objects A and B. Heat will flow from higher temperature to lower temperature, in this case from A to B. This is not necessarily a flow from an object with more internal energy to another with less internal energy. As you can see in this example, object A has less internal energy than object B. Yet, the flow is from A to B because A is hotter than B. The flow of heat continues until there is no longer a temperature difference. This is one possible configuration when the flow of heat stops. Object A now has internal energy of 57 joules and average kinetic energy, which measures the temperature, of 19 joules per atom. Object B now has internal energy of 95 joules and average kinetic energy of 19 joules per atom. The two objects' temperatures are now equal. The heat stops flowing in this condition, which we refer to as thermal equilibrium. Notice again that the final internal energies of these two objects are in general different. What must be the same, other than the final temperature, is the heat released by object A and the heat absorbed by object B, provided the systems are isolated from everything else. So another way to describe the heat is that this quantity is just the difference in internal energy. QA here is delta UA, UA after minus UA before. 57 joules minus 72 joules, which is equal to minus 15 joules, while QB is 15 joules. Negative Q or heat indicates that the object releases energy, and positive Q means the object absorbs energy.